Welcome back. We are happy to have all of you join us again. I hope you're refreshed after your lunch and now your appetite for more information and insights has only increased. Now we're going to talk about gasification and how it can be a game changer for production of chemicals and synthetic fuels in India. So chemicals is that category where there's a lot of consensus that gasification works really well. Now, coal consists of carbon-based substances which can be used as a source of specialty aromatic chemicals and aliphatic chemicals. The process that could be used for this include gasification, liquefaction, direct conversion, and co-production of chemicals and fuels along with electricity. Now, currently, oil and natural gas processes are more mature and widespread, and hence widely used for converting hydrocarbons into chemicals. Emissions are also lower, but coal reserves far exceed oil reserves in India. We have very few oil reserves, and actually coal reserves far exceed oil reserves all around the world. Can innovative technologies make it lucrative to convert coal to chemicals, even if oil is less than $50 a barrel? So, coal is usually more abundant than oil, with the exception of the Middle Eastern countries where oil reserves are well known and established, are plenty. But what we want to know is it going to be economical to get to convert coal into chemicals when the possibility of cheaper oil is quite real in the near future? To speak on this, please welcome our speakers. We have Mr. Moniz, Vice President, Global Gasification Licensing, and Shibaditya, Director of Business Development, Air Products. We also have with us Mr. Rahuel George, Country Head, Case Group. We've heard him before in the day. We have Mr. Cristian Bolda, General Manager Operations, Leigh Creek Energy, and we will be joined by Mr. Damodar Mittal, Executive Vice President, Jindal Steel and Power Limited. A warm welcome to you, gentlemen. And Mr. Moniz, I'm going to ask you to make your presentation on, there is a consensus that chemicals make a lot of sense from the carbon in coal. But we had one speaker who said, you have to maximize the value of coal, and just energy is not going to be enough, will not be lucrative enough. So along with chemicals, how do you maximize the value of coal?
Well, let me begin by saying thank you. Thanks to Anisha, and on behalf of both Shiba and myself, I want to thank the organizers for giving us this opportunity to present to you today. So let me start. We have a few slides. I'm going to go first, and then I'll give it to my colleague Shiba, and he'll cover the second half of the presentation. So what we're going to talk about in the next 30 minutes, just like Anisha mentioned, is gasification that has a game-changing opportunity, a significant opportunity for India, very much along the lines of what you just heard from Anisha. It's chemicals, it's fuels, it's clean energy. So if we think about gasification as a technology is not new. We all know that. In fact, it's been used for hundreds of different gasifiers in different parts of the world, really all regions of the world, and over about decades of time. So it's a very proven technology. Yeah, so again, as we're talking, it's a game-changing opportunity for India. It's a significant opportunity. And just along the lines of what we just heard from our moderator, Anisha, the significant savings is the reduction of foreign exchange from the opportunity to use local indigenous coals from India, right? So if we look at gasification, we take it in totality, and we look at gasification from across the world, what's been done over the past 3 decades of time. You're basically taking disadvantaged fuels, such as coal, such as maybe even petroleum resid, petroleum coke, and you have the opportunity to convert it to syngas, very clean in a very environmentally acceptable manner. And from the syngas, as you see on this pie chart, you can make a bunch of different chemicals, very basic chemicals like ammonia, methanol, and then onward from there, you can go on to fertilizers, olefins, fibers, petrochemicals, etc. So if you look at this pie chart, there's the potential for making a number of different chemicals in India that are today derived from oil and natural gas, which has very high imports. And then there's also the possibility to make a different type of product slate. Middle distillates, such as liquid fuels, that you see on the left-hand side of the pie chart, SNG, power, clean power. So whatever the demands may be for the local region of India. So the opportunity, again, as Anisha mentioned, is to save foreign exchange in the range we think of about $10–15 billion is very possible in the next few years. Okay. So if we go into just a little deeper dive, and we just look now at the energy mix by fuel in India. So if you look at this bar chart, I won't go into a lot of detail here. I'll just take the highlights, and we'll just concentrate on the two middle bars shown in this bar chart. If we look at the second bar, that's the total primary energy supply. And then we look at the third bar, which is the total final consumption of fuels. You'll see that, yes, coal, which is the brown color, is used just as most countries in the world. But then a large portion also is oil and natural gas, which again, many, many countries use for their energy needs. But that there is the opportunity to convert some of that oil and natural gas, which is imported. And if you look at the bottom of the slide, you have as much as $100-some billion of imports that are coming year into India of foreign exchange. And there's about $10 billion of, again, foreign exchange used for LNG. So whether we look at this slide, which is both the fuel, or the prior slide, where you can make basic chemicals and onwards onto more advanced chemicals, that is this game-changing opportunity that's available to India by a very proven, well-understood, low-risk technology. So how can Air Products, how can the company that Shiba and I work for, how can we work with you for companies and opportunities to bring this game-changing opportunity to your region and your part of the world? So this is just a very summary slide. In fact, Shiba will cover the slide in more detail in a few minutes. So at this point, I just want to say a few words. The scope of Air Products is the middle of this slide, shown in blue. And basically, what we do is we'll take any feedstock that you give us, hydrocarbon feedstock, coal, coke, any disadvantaged base fuel feedstock, and we will transform that in gasification and all the associated unit operations into any product, just like we talked about in the first two slides, that is required and needed in that region. So it could be a chemical, it could be a fuel, it could be syngas. I also just want to point out again, Shiba will go to the slide in a little more detail. We also have CO2 capture technology. It's proven and it's demonstrated that Air Products has done in Port Arthur, Texas, for example, for many, many years. So for those companies or that part of India that may be interested in carbon capture to make it more carbon neutral, we have that capability too. And again, the build, own, and operate, which is this middle section, this blue section, that will be Shiba will do a deep dive into that business model. So I just want to cover this in summary for right now. So if this is the business model and this is what Air Products can bring to you, you may ask, so what's your experience? What have you done in gasification? And why should I be working with you, right? It should be a very fair question. So let's speak about that right now. So here's our, just in short summary, our experience that Air Products has had. Actually, it's in the past few years, we've used gasification in our plants as a customer, as some of you might be or might be interested in. But only a few years ago, we actually started with acquisitions. And in 2018, we first acquired the Shell gasification technology. So this is a dry feed technology, as some of you may know. And then in that same year, we actually bought the GE gasification technology, which is very complementary to Shell. It's more a slurry-based technology for different types of coals, different types of feedstocks. So between Shell and GE, it gives us a very broad span of taking in, honestly, any different type of coal or petroleum coke or resid. It's a very broad range of feedstocks that we can handle. And what these two technologies brought to Air Products is literally hundreds of gasifiers through their licensees, which now is owned by Air Products. And that was a lot of experience, a lot of intellectual property, and a lot of people with this broad experience spanning about 30, 35 years of gasifiers up and running in all parts of the world. And then we've taken this experience and we got very busy. So as you can see, as we step up this ladder, we've done many build, own, and operate where Air Products, either on its own or through joint ventures, has invested several $1 billion, and we'll go through all these different projects. As you see in the stepped ladder approach, there's 5 different projects here. So in the next 5 slides, what I'd like to do is cover these 5 different projects. And then I'll turn it over to Shiba, and Shiba will do a deeper dive on build, own, and operate. So let's start with our first project. So this project is with Saudi Aramco. It happens to be in Jazan, a new economic city in Saudi Arabia. And it is a very large IGCC. So if you look in the first bullet, the scope of this project, the main product of this project is 3.8 gigawatts of IGCC, which is a very, very large amount. It's almost the power consumption of the country of Denmark from one project. And it also makes a lot of steam and energy in a very clean manner. The feedstock here is vacuum residue from the Aramco refineries, right? This is Saudi Arabia, so it's not coal. We're talking about vacuum residue from the Aramco refineries. And it's a very large project. The capital, if you look to the bottom part of the slide, it's about $11.5 billion. And Air Products is running this project in a joint venture with a number of entities shown in the ownership bullet. I'm going to move on to the next project. And this is our Luan Clean Energy project. This is in Shanxi region, in Shanxi province. Shanxi is in the middle part of China where there's a lot of coal, a lot of different types of bituminous and anthracitic coal. In this particular project, Air Products has 4 pretty large, it's 3,000 tons per day per gasifier. This is the dry feed technology. It's the shell-based technology. And basically, we are using these gasification units, all 4, to produce 16,000 tons a day of, the air separation 16,000 tons a day, but we're using it to produce clean fuels. If you remember the pie chart, we can make chemicals as well as fuels. India is doing a lot of import of fuels. You have the potential here not only to make chemicals, but also in this case, liquid fuels, which is used in the local region. Here we have a joint venture with the company. It's a 60-40 joint venture, and the capital expenditure is about $1.3 billion. We've been on stream in this project, and 2 highlights in the bottom bullets. One that we're very proud of, the carbon conversion rate we have seen consistently for these 4 gasifiers. It's the legacy shell technology. It's dry feed. Has been running above 99%. It's a very clean way of converting carbon, in this case, to a fuel that's used locally. We've also had a very good run rate on the gasifiers, and for last year, the full 2019, the on-stream factor was just in excess of 95%. So we'll move on. So in this one, I just wanted to take you to something we recently announced, and then we'll go back in time. So this is a project in Indonesia. And as you see in the map on the right-hand side, in this particular case, the location is going to be in East Kalimantan Island on the eastern part of Indonesia. And here, we're actually using a poor quality coal. It's very high moisture, also has very high ash content. But again, our technologies that we have in-house today through our acquisitions can take this coal and convert it. In this particular case, we're going to make methanol, coal to methanol, pretty standard gasification process. So about 6 million tons of coal will be used to make 2 million tons of methanol. It's about a $2 billion capital outlay, and this will be a standalone Air Products project. Very recently announced, should come on stream within the next 4 years. And we move on to the next project, and this is Jutai in Hohhot, China. In this particular case, we have 2, not as large as Luan, but these are also significant. It's 2,000 tons per day Air Products gasifiers. And we are going to, in this case, this is making MEG or monoethanol glycol, and the customer eventually will take monoethanol glycol or MEG and make polyester fiber. This is also a standalone Air Products project, about $650 million capital outlay. Construction is going very well. We expect to be up and running within the next 2 years. And last, before I turn it over to Shiba, and Shiba will talk to you a little bit about a couple of India projects, but the last one I just want to share with you is actually a smaller project. It's a smaller project. And we, again, the size range from very small to very large. This one is 2 750 ton per day slurry gasifiers. And basically, we're doing this with the Debang group, Debang in the Jiangsu province in China, and we're converting it to chemicals, different chemicals, about 350,000 tons a day, so much less than 1 million. So again, gasification can be done at reasonable scale. It obviously can't be done at very small scale because then the economics don't work, but it can be done well below 1 million tons per year, and we wanted to demonstrate that here. This too will be a joint venture between Air Products and the Debang Group, and the capital outlay is about $250 million. So I just want to give you a flavor. Remember the pie chart, right? Gasification is very versatile. The pie chart we showed earlier, it can be taken to many different types of chemicals, methanol, ammonia, and then onwards. Also distillates and also IGCC such as power. And those were some of the examples I shared with you. So now I'd like to turn it to Shiba. I will move to the next slide, Shiba, and Shiba will take you through a couple of projects in India and then a deeper dive into our build, own, and operate model.
Yeah, thank you, Mario, for a very nice presentation. So thank you very much, Mario, for passing on to me for the next couple of slides, few slides. And good afternoon to all of you present here. So I will first, take you through some of the projects we are currently executing and will be perhaps executing in the current future, which are very large gasification projects coming up in India. So one of them you might have heard is the Talcher fertilizer, which is a joint venture of GAIL, Coal India, and RCF, and also FCIL, located in Talcher. And this will be a very large project and one of its kind in India, where very high ash content coal of the Mahanadi coal fields will be converted into ammonia and then to urea. So here we as Air Products has been selected by the client as the technology licensor, and we are offering our dry feed coal gasification technology, which is highly suited for high ash coal, especially for Indian type of high ash coal. So there, this project has already been awarded on an EPC contract basis last year, and the project is under implementation. And we are the technology licensors for the gasification part. So there, basically, this is the first story where Air Products has become the technology licensor provider for a very large scale coal to ammonia and urea project. The other one which is coming up shortly, you might have heard, is a Coal India project, which is going to convert coal into methanol in the eastern part of the country near Kolkata city, a location called Dankuni, where a relatively low ash coal from Raniganj coalfield will be used to convert to methanol. And this is a pretty large plant, about 2050 tons per day of methanol, and based on our dry feed technology again. But again, this is not under implementation. This is currently under planning and under the bidding stage. But we hope that we will get an opportunity to work on this project. So these are the two large projects we can see currently in the pipeline. There are several more projects coming up, as you may be knowing, as Coal India Director Technical has told yesterday about the Central Coalfield, Western Coalfield, and also the Southeastern and Eastern Coalfield. They are also planning for very large coal to chemicals projects. And Navali Lignite is also planning for lignite to methanol, as well as some other companies, some other entities like TITCO also, which we heard that they're also planning for similar lignite to methanol projects. So these would definitely open up a lot of window for us. And of course, we'll be in a position to, if not able to meet 100 million tons, but maybe move closer to the target as close as possible with these large projects. Okay, so I'll just keep that. Okay, so now coming to a very important aspect, as Mario mentioned earlier in one of his slides, that the contracting philosophy in India in the past had been conventional EPC, where the customer client used to select the technology licensor, and they would then either implement the project by themselves, or they will select an EPC contractor to build the plant. So that we typically call it as a sale of equipment model, or SOE. And in that case, the customer is investing in the entire capital expenditure, and the customer is taking all the risk in terms of technology risk, construction risk, and operations and maintenance risk throughout the lifetime of the project. Now, what happens in the build and operate is companies like Air Products, we are in a position to finance these projects, multi-billion-dollar projects in India and elsewhere in the world, as we are doing, as Mario has explained in some of those examples, where we bring our own capital and with our own technology, in-house technology, we build the plant in a certain time frame, and then we commission and own and operate the plant, and we enter into a long-term agreement with the customer for the product offtake. So the product could be a syngas, or the product could be any other chemicals like methanol or ammonia, or any other products, as Mario has explained in the pie chart. So this actually, we call the BOO supplier, the BOO operator, as Air Products, will be providing the entire capital to build the plant, to design and build the plant, and then we will own and operate the plant for a long term, typically 20 to 25 years, and enter into a long term agreement for product offtake. And here, Air Products will take full responsibility in terms of operating and maintaining the plant over a long period of 25 years, and we will take all the risks, including the construction risk, the operations risk, the technology risk, and we will give long-term guarantees in terms of reliability, availability, and also energy efficiency and process efficiency levels. So in a way, we are actually de-risking the customer and also bringing in proven technology with capital and investment, which is also a part of investment will be FDI, foreign direct investment, which is also encouraged by the government of India. That more the FDI, the better now. So obviously, we will be bringing foreign capital to some extent with a lower cost of capital, which advantage will pass on to the final end user in terms of lower cost of or cost of production of the chemical. And we may be able to even supply multiple customers from a single plant. So the economies of scale come into the picture. Like in a cluster situation where there are multiple customers, we build a bigger scale plant, and we can supply from the bigger plant to 2 or 3 customers, and that would enhance the economies of scale. So of course, this particular slide Mario has already explained to some extent, but I wanted to make a little bit of deep dive in terms of how we offer this build on operate, or as we call it, sale of gas model to our customers worldwide, and what benefits it brings to the end user or the customer. Now, in this diagram, as you see, it's a simplified diagram where it shows the responsibility or the scope of the customer and Air Products as a build on operate entity. So customer needs to give land, all the clearances and permits, and obviously customers to give the feedstock, which is mainly the coal or pet coke, or it could be refinery residue in case of a refinery, and some of the utilities like power and water. So these are the basic things what we need at our battery limit. Anything within that blue box, as you see, would be built, would be invested, built, owned, and operated by Air Products. So right from the handling of the coal, the feed preparation section to gasification, air separation, sulfur recovery, rectisol, which is the acid gas removal, and finally the clean syngas going into the chemicals manufacturing, could be methanol or ammonia or anything else. So that part of the entire facility will be built by us, owned and operated by us. And as Mario has already explained, there are multiple opportunities in terms of multiple products we can look at, like ammonia, methanol, syngas, hydrogen and carbon monoxide, and also synthetic fuels like CTL, as we call it, coal to liquid, or even SNG, synthetic natural gas. The units, which is the acid gas removal, produces a very high concentration of CO2 stream, which is capture ready, and we can use that CO2 either for enhanced oil recovery, or we can use it for further manufacturing of other chemicals based on CO2, or for sequestration. So CO2 capture ready is very important in our current date, and a current environment in terms of reducing the carbon footprint. So here, the business model is Air Products will build, own, and operate for a long term, 20-25 years, and the end products will be supplied to the end customer based on certain guarantees, long-term guarantees, as I've mentioned. Coming to the next slide, this is a very simple slide, but I want to explain how the risk matrix changes between a conventional EPC to a BOO mode. On the left-hand side, if you see, the second column is where the customer is making their own product through their own captive production. So there, the customer has to basically finance the entire project, will have to construct, commission, and operate by themselves. And the efficiency, availability risks, and even the technology risks lies with the customer. And even the costs could also vary in terms of implementation cost typically goes by the end of the project there could be cost escalations because of various reasons. So what we do is we take over all that risk from the customer or the end user, and we bring in the capital, we build the plant and own and operate, and we give all kinds of long-term efficiency and availability guarantees. And we also give a very predictable cost structure, in the sense that when we sign the agreement upfront with the customer, the cost structure is already known, that how much customer has to pay every month in terms of a conversion charge. So there is no surprise at the end of the day that the cost would go up for the customer. So it's a very predictable cost structure for the entire 25 years period. At the same time, we also guarantee the startup date, that is the project schedule. So we will be able to we will have to ensure that the project is done on time and commissioned and started up on time. Otherwise, there will be penalties also in the contract if you are not able to reach those guarantees. So this is a typical supply structure built based on a coal to methanol as an example. So on the right hand block, Air Products will own and operate all those entities like ASU's gasification unit, the syngas purification unit, and the methanol or ammonia production unit, and it could be even urea also, and would supply over the fence to the customer or the client, which could be any private or even a government entity like a PSU, like Coal India, for example, or it could be IOCL, for example. What we need is prepared coal or pet coke as a feedstock. And only one thing is very important, is the customer has to take care of the end market, which means they will have to take care of the final marketing of the product. And we are basically giving long-term guarantee as a sort of an operator, BOO operator, including the investment part. So what are the benefits of the BOO model, as we say in India, build, own, operate? So Air Products will invest, own and operate, and we will guarantee the plant performance backed by significant financial incentives, as I've mentioned. And there will be even penalties if we are not able to achieve those targets in the contract. So there will be complete capital avoidance by the customer or the client, which means Air Products will invest in the capital. So it's a $2 billion project. The entire $2 billion Air Products is going to bring. And we will guarantee the availability, that is percentage on stream factor. We will guarantee the reliability of the plant efficiency in terms of the energy efficiency, that is the specific consumptions. And we will also guarantee the product specification, the operational cost, and also guarantee the build schedule and the cost of putting up the plant. So which is basically the construction cost and the schedule cost. So these are the benefits of build and operate model, and this is a game changer, as we are saying, in terms of accelerating this process of putting up more number of coal gasification projects. Because what is happening is customers may be hesitating that whether this technology would work, whether I'll be able to generate that much of fund, whether there is an inherent risk in the project, or even whether the project is viable or not. So there are several questions which comes and typically delays the whole decision making process. So here we can swiftly move in as a BOO operator. We can take away all those risks and give long-term guarantees and operate these plants immaculately and very, very smoothly over a period of time with and Mario must have he has already showed how we are operating the Luan plant, which has been operating for last 3 years. It has already achieved its full capacity and also very high availability factor as of now. So we have demonstrated that worldwide, that we have capability in terms of operational excellence, in terms of bringing in the capex of multi-billion-dollar projects, and also our own capability in terms of being a licensor and also our own engineering strengths to build such very complex gasification projects. And most importantly, I wanted to highlight that there are several units in a gasification. The gasifier is not the only thing. There is an air separation unit, there are rectisol, there is a shift reactor, there are various other processes, and also the downstream units. So if anything goes wrong in terms of the process integration, the entire project may fail. So it's very important that one entity takes entire responsibility in terms of the process integration and guarantees the whole process right from the coal intake up to the product offtake. So that is the concept we bring in the build and operate. Now, I would like to just go through a couple of slides in terms of Air Products, what we are in India. We have a very large build and operate facility in Kochi. I think you can see the photograph. which was a long-term 15 years agreement build on operate signed with BPCL for supply of hydrogen, nitrogen, and syngas. And we also operate a captive power plant, which is a gas turbine, as a part of this BOO facility. So about almost $500 million of worth of investment has been invested by Air Products, and we are on a 24/7 basis supplying hydrogen, nitrogen, oxygen, and other products. And now we'll be also starting up our syngas plant very soon, which will be supplying syngas to the oxo alcohol and acrylate project, which is the downstream petrochemical of BPCL Kochi. So that was my presentation in terms of overall, the offering what we have. As we have explained, Mario has already explained our strengths, international strengths in terms of what we are doing globally. And I have tried to give you a flavor in terms of what the business model is all about. And of course, our BPCL is a very large investment, which is already operational. You are all welcome to see the BPCL plant. Anytime you can approach us and we can take you to the plant to have a look how it is working. So thank you very much for this opportunity.
Thank you, Shibaditya, and thank you so much, Sir Mr. Moniz, for taking us through the presentation of Air Products. I would now like to ask Mr. Rahuel George, the country head of Case Group, to please give his presentation.
Very good afternoon to everybody, all present here. It's always wonderful to be part of this conference. We've been taking part in this conference for almost like 10, 12 years since the time it was, it started off. And great achievement by Mission Energy. I would like to congratulate them for giving us technology providers a platform to share with you all the technological advancements that happen in the gasification industry. Well, I'll start off with my presentation. Okay, wonderful. So I have a couple of notes which I would be taking up. So firstly, we would like to talk about what is coal gasification. In a very basic terminology, we would define the process of successfully converting a solid fuel, which happens to be coal in this case, to a gaseous fuel, which could be coal gas, producer gas, or syngas. It sounds very simple, but then a lot of technology goes in that. What are the various gasification technologies which are available today? Coal gasification has a huge history, and as of now, the following technologies are prevalent in the industry. We have the fixed bed coal gasification. Moving on, we have the circulating fluidized bed coal gasification. Then we have the entrained flow gasification. And finally, the UGC coal gasification, which was talked about in the first session. And there was always one gentleman from Ergo who used to come up for this presentation, Dr. Blinderman. I remember him. Unfortunately, he is not available today to discuss this. So I think someone will be taking up this in the future. So once the gas has been formed, the gas can be used in a number of ways. This is a value chain which I'm trying to show you here. The coal is converted to gas through the gasification process. And there are two primary uses of this gas, as I was explaining earlier also. One is the thermal usage of this gas, and the other is convert this gas into syngas and further use it for different applications where you can make liquid oils, you can make synthetic natural gas, fertilizers, steel, power, etc. Where do we pitch in this value chain? We as gasifier people, we basically play with the coal gas and use it as the heating or the thermal use of this gas. So I would like to explain you the technologies which we are using here for this. Now, depending on the physical properties of gas, and more importantly, on the gas temperatures at the gas station exit, we have categorized our technologies accordingly. The first is the hot coal gas, in which we have the variants of a single stage hot gas station. Then we have a pyrolysis hot gas clean gas station. Then we have a circulating fluidized bed hot clean gas station. On the category of coal gas, we have the pyrolysis clean coal gas station, the pyrolysis ultra clean coal gas station, and the circulating fluidized bed clean coal gas station. As for the syngas, we have recently tied up with KEDA. They are the pioneers of this gasification technology in China. So we're doing in-train flow gasifiers with them for this. Now, my next important section which I want to cover up for gasification is that whenever we talk about coal or we talk about gasification, there is always an element of doubt in the mind that whether this technology is clean using coal, will it be okay for the environment? What are the issues that can happen because of this gasification? How harmful would it be for the environment? So I've categorized all these in four basically categories which are related to air, water, and noise and ground this thing. So for air related, we would say that dust content in gas resulting in higher SPM and RSPM levels, sulfur content in gas which accounts for higher SOx levels, higher N2 content in gas resulting in higher NOx levels, the poisonous nature of CO, which is the main constituent of gas, which can be fatal. Then whenever we're using coal, obviously there is a generation of coal dust, and the smell or the odor of gas is also one main concern. So these are the air-related concerns which are picked up by the environmental authorities in India here. Second is the water-related issues. With the process of gasification, there is always a generation of tar and light tar oils. Phenol and condensate water is also one of the byproducts of this gasification. Then cooling tower blowdown. Whenever you're using a coal gas system, you need a cooling tower in which wherever you evaporate water, you need to blow down the water in order to maintain the TDS levels. And then you have these water seals. A number of water seals are there in coal gasification systems which need replenishments and they overflow at times. So what do we do with that? And the third is the noise-related issues. The primary sections where you get this noise are the gasifier air blower. These are big blowers which make a lot of noise. And then there's a gas boosting station or the pressurizing station. Again, all these are because they are the rotating sections of the gasifier, thus they make a lot of noise. Then finally, we have the ground-related issues. Whenever we're doing gasification, there is ash which is generated. Then there is coal dust which is carried along with the gas. And in case of CFBC or the in-train flow gasifier, there is the handling of fly ash and slag which needs to be taken care of. So our technology is primarily, we have divided it into two parts depending on the feedstock. The first variant of our gasifier in which we use size coal would be the single stage hot gas station. This is a very simple design gasifier in which coal is fed from the top. The air and steam, which is the gasifying agents, are injected from the bottom. The gas is generated, passed through a water seal, and then through cyclone separators, and then taken for utility. The best thing about this gasifier is that the gas outlet temperatures are more than 450 degrees. Because of this factor, we have played with the physical property of tar and that of water. We know that below 350 degrees, the tar, it starts condensing into liquid. And below 80 degrees, it starts solidifying. And we all know that water always stays in moisture state, in vapor state, above 100 degrees. So in this technology, we are taking gas at 450 degrees and making sure that all the tar and all the volatiles stay in gaseous form. The condensate water or the phenols remain in vapor state and crack into carbon dioxide and H2O at point of utility, which is the burner or the point of usage. And these are fully sealed design, eliminating chance of gas dispersion into the atmosphere. So there is no gas leakage in this kind of a system. We are using coal of more than 20 mm size, so the chances of dust being a part of the gas is completely eliminated from the system. So the gas that comes out is relatively dust-free and tar-free, and there is absolutely no phenol or anything like that generated in this system. So this is a simple process design of this. This is the gasifier. I don't know if you can see my pointer. This is the gasifier. You have the air blower. Then the gas is generated. Air and steam are injected from the bottom. It passes through a water seal. Basically, it's an isolator also. Works like an isolator. When you want to cut off the gasifier from the main system, you raise the water levels, and then the gasifier is isolated from the utility point. There is a small cyclone dust separator here, which takes care of the heavy dust content in the gas. What are the best features about this gasifier is that it has highest gas calorific values that they can touch up to 1800 kcal per nm cube. This is because it is a combination of the calorific values of coal gas, the volatiles that are there, and also the gas sensible heat which we are generating. The gas, as I told you, the temperature is around 450 degrees for this gas, so we get the sensible heat of the gas at the utility point. Then most compact design, you can see from the process flow, it's a very simple design. There is a gasifier, water seal, and cyclone and utility. Nothing much happening here. Then high calorimetric temperatures, depending on air recuperation efficiency, this gas can reach furnace heating temperatures up to 1600 degrees. We have tried this gas for very high temperatures where glass melting is the application. You require temperatures around 1500 degrees plus. So these gasifiers are very effective there. And also for insulator heat treatments, where you require temperatures around 1380. These temperatures are basically in reducing. There's a reducing atmosphere in the process of insulators. So there also these gasifiers are very effective. One more very good important aspect of this gasifier is it's quick to start and stop. You can turn it on in less than a minute. You can turn up from 10 degrees to 100 degrees within a minute. So these are very quick, small gasifiers for small applications, and primarily used for the thermal use of gas. Then a second variant is the pyrolysis hot gas station. Here the gas temperatures are 150 degrees. We call it hot because it's above 50 degrees. Anything below 50, we call it as coal gas system. This is like a single stage gasifier, but the height of this gasifier is almost double to that of a single stage. We have an addition of a pyrolysis section in this gasifier. Coal is fed from the top. The air and steam are injected from the bottom. The oxidation reduction reactions take place along with another reaction, which is the pyrolysis reaction, where the volatiles of the coal are cracked into hydrocarbons, and then we pass this gas through a tar washing tower and then through a tar electrostatic precipitator in order to reduce the tar content of the gas, and then take it to the compressor or the booster and push it to the utility. The important features of this are that uncracked tar and volatiles from the gas are extracted in first and single stage purifying sections, which happen to be the tar washing tower and the electrostatic tar precipitator. And then the condensate water phenol remain in vapor state as the temperature is always above 150 degrees. All the phenols and water remain in vapor form, and they are cracked in the utility point at the burner wherever the usage of gas is. Then these are again fully sealed design, eliminating any chance of gas dispersion into the atmosphere. For these gasifiers also we are using sized coal which is more than 20 mm, thus eliminating the presence of coal dust in the gasification process. The third variant for this sub-variant for the pyrolysis gasifier is the pyrolysis coal clean gas station. In this process, we add an indirect cooler to the already explained process of pyrolysis. The purpose of putting an indirect cooler is to take out the moisture content of the gas. Here we call it the cold gas, as the temperature is reduced and got down to less than 50 degrees, or we call it, it's more of an ambient temperature that we give. The whole process is the same as of the previous slide. The addition of an indirect cooler where the gas is made to cool down and the temperatures are reduced to 50 degrees. Because of this, a third purifying system is incorporated, which is an indirect cooler. Then condensate water treatment system is added because since we take out the condensate water from the gas, we need to have a complete treatment process for this. So we have incorporated a condensate water treatment system, and thus we eliminate 80% of the moisture content from the gas. Then treated condensate water usage system is added, as I explained to you, because what we do is we treat this condensate water and reuse it 100% in the gasification process. Where, as we know, that we require steam for gasification. So the condensate water, we take it in our gasifier jacket, and we convert steam of that and put it back into the gasification process. Now, this is very important as to how we are able to treat the condensate water. This is our main technology, what we're doing, as I told you. We are playing with the physical characteristics of the two most important impurities of this gas. Number one is the condensate or the phenol water that comes out from the system, and the second is the tar that is generated, the tar and the oils that are generated. Now, what happens if you see the parameters of the gas here? The temperature at the exit of the gasifier is maintained around 120 to 150 degrees. So in this case, in this condition, most of the tar in the tar washing tower and electrostatic tar collector, most of the tar is extracted from the gas. Because of this, because of the feature of this property of tar, it would liquidify here, and then we take it into an underground tank and we reuse it in our system. Beyond this point, we take the gas and pass it through an indirect cooler, reducing the temperature. Thus, here we condense the moisture from the gas. This is basically what we do is, in the first two phases, we are taking out the tar from the gas, and in the third stage of purification, we take the moisture out of the gas. So we are taking the tar and moisture at different stages of the gasification purifying systems. This is how we are able to do this. Once we take out the condensate from the water, we need to reuse it back into our system. So our gasifier basically is it has got three shells. It is divided into three parts: the lower shell, the middle shell, and the upper shell. Now we are using this treated condensate water in the lower and the middle shell, and we have attached these vapor drums here. By which the treated condensate water is converted into steam by the heat transfer that happens in the gasification shell, and this steam which is being generated here is pumped back into the system as a gasifying agent along with the air. So gasifier lower water jacket we are using for the condensate water, treated condensate, and also the gasifier middle water jacket, which is here. We use condensate water. This is how we are 100% consuming this condensate water, and we are not disposing any of it into the into the drain, or we are not throwing it off as an effluent. Then we have another variant for the pyrolysis called ultra clean gas station. We call it. We have added another ESP, or electrostatic precipitator, to it. This is basically some of the applications require very pure gas, something like less than 30 ppm of the tar and dust in them. So for this, we have come up with this this process. And by adding another fourth stage purifying system or the electrostatic precipitator. This also reduces volatile and dust levels in gas, as I told you, to less than 30 ppm, making the gas relatively cleaner for applications such as for food industry where you have biscuits or things happening like that. So this is more prevalent there. Then we reduce moisture contents also to less than 20 grams. In turn, we increase the net calorific value of this gas by 10% by extracting the moisture and reducing the dust levels. What are the why do we call this gasifier to have a edge over the other gasification technologies? It's because of the consistent gas quality which comes from it at all times. We have observed that using this technology on different coals, we have been able to generate the same calorific value of gas at all times. It is basically, I would say that it is independent of the quality of coal that we use. We are able to get the same CV of the gas. Secondly, there is less fluctuation in this gasifier. Since this is a single line process, all the equipments are in series, so there is very less fluctuation in pressure, where you have gasification technologies in which you have two-stage gasifications in which you have one gas coming from the top, one gas from the bottom, and then you're mixing the gas. You have different purifying equipments for the top gas, different for the lower gas, and then you're mixing it. So there are a lot of pressure variations in that. But since this is a very simple design, a single flow design, so there is less pressure fluctuations in this. And this is a fully automatic PLC controlled system. Very less manpower required for this. Only for sitting at the DCS and operating these gasifiers. Very important part of this is these are refractory-less, non-clogging gasifiers. When we initiated these gasifiers in India, the top section of this gasifier used to be refractory lined, but over a period of time, we saw that the inside of the refractory used to get choked up. So we came up with this technology by understanding the complete thermal, heat transfers and all. We converted the top section of the gasifier also to a water jacket. So we were able to get over this clogging problem that we were having in our previous gasifiers. So this is one research and development which we did for this technology. Then these are designed on all ZLD technology, which is a zero liquid discharge. As I told you, whatever liquid that is coming out from the gas is very professionally handled. The condensate is collected, treated, and used back in the system. So there is absolutely no discharge into the atmosphere. Nothing is going into the atmosphere. You're not polluting the rivers. You're not polluting the water. You're taking care of the environment 100%. Then these gasifiers have a very high rate of gasification. For other gasifiers, we have studied over the past that for our model of say a 4-meter gasifier is able to give gas of roughly around 6,000, anything between 6,000 to 12,000 meter cube, depending on the quality of coal. Whereas the other gasifier technologies which are available in the market today, they are not able to go above 4,500 meter cube. So the gasifying rate for these gasifiers is quite high. So what I'm trying to say is that if you're going in for a different technology, probably you will require double the number of gasifiers as compared to what this technology can offer. Then we have incorporated world-class safety standards for this, since we're talking about gas, which is anyways a very dangerous commodity. So we need to make sure that the world-class standards are met, not only in the process but also the usage of gas. Now we move on to our next gasification technology, in which we use coal fines. For this, we have recently collaborated with CADA. CADA is the pioneers of CFBC technology in China. They are the giants of this technology, and with a reference of roughly around 80 to 82, running projects. We feel that India is now ready for this technology because of the amount of sized coal, the availability of coal is reducing, and we need to find technologies in which we can use coal fines for gasifying. So that's how we got in touch with them, and we have a joint technical collaboration with them, and we are introducing this technology in India now. This is the CFBC hot clean gas station. This is the process flow for that. Gas temperatures are above 150 degrees for this technology. That's why it's called a hot clean gas. The gasification temperatures range from 950 to 1000 degrees centigrade. That is the reaction temperatures inside the gasifier. This is the gasifier. The pressures are designed at 20 to 30 kPa, and the gasifying agent, which happens to be, which is air here, is injected at the bottom of this gasifier. The temperature of this are kept around 700 to 750. This is a very simple design. Again, it's a series of, it's a single line process in which you have the coal coming in. Coal is injected at the lower end of the gasifier. Air and steam, which is your gasifying agents, are injected from the bottom. You create a circulating fluidized bed system here, and then the gas is generated. The oxidation reduction reactions taking place here, and then this gas is passed through a cyclone separator because of the any heavy particles that are there in the gas are recycled back into the gasifier for further processing. The size of coal that we require for this is less than 10 mm. The gas coming out here is around 900 degrees. This is made to enter into a heat exchanger, which we call as the HE1. It's also a recuperator for the combustion gasification air, which we are using as a gasifying agent. We inject, we blow the air into the heat exchanger. This is an indirect heat exchanger. The gas is coming at a 950 degrees. The air is ambient, gets heated up, and then it is injected into the gasifier at the bottom. So we are utilizing the entire sensible heat of this gas. Further, this gas goes into a secondary heat exchanger where we have it's a water cooled heat exchanger where we are making steam out of this. Again, an indirect heat exchanger. Then after this, the gas around 150 to 180 degrees is made to enter the filtration area. This filtration area makes sure that all the fly ash that is there in this gas is captured. We try to keep dust contents less than 20 ppm by this, and we do not have any further cooling to this gas, and we take it to the utility. Depending on the pressures required at the utility, we put a booster, or we don't. It depends on the pressures required at the furnace or the utility points. The next variant for this gasifier is the CFBC cold clean gas station. Similar to what we saw in the previous slide, in this we have introduced two heat exchangers. These are water-cooled heat exchangers in which we are reducing the gas temperature from 180 degrees to ambient temperatures. This is the 3D view of this gasifier. What are the technology features of this gasifier is number one, that you are able to 100% substitute high-cost fuels. You're able to substitute the use of heating oils like HFO, LSHS, for your LDOs, SKOs, your natural gas, your propane, LNG. You are able to 100% substitute it for your thermal applications. Then low-cost, readily available coal fines can be used in this technology. As I told you, fixed bed is having a limitation now as the time is going on. The availability of sized coal is becoming difficult. So this technology is the future for gasification in India for the thermal application. So here you are able to use low-cost available fines. Then these are fully automatic, zero manual intervention gasification stations. We happened to visit KEDA, a few of their installations in China, and we were surprised to see no one at the gas station, only a few people sitting at the DCS, and the system is running 100% on auto mode. And the beauty of the system is that there is a one-stop button system for this, If there is any problem in the utility of gas, or if there's any problem in the gas station, you need to just press one button and everything will sequentially close down, and it would be the safest gasifier practice we have seen till date. Then there is no tar because all the volatile matter there is no retention time for the volatile matter or the coal in the gasifier. So 100% all the volatile matter is converted into gas or hydrocarbons. So there is no tar in this technology. There is no phenol happening because everything is cracked within the gasifier shell itself. Then dust contents less than 30 mg can also go to, depending on the application, we can go up to less than 10 mg as well. Gas calorific values are greater than 1300 with oxygen enrichment, or using 100% oxygen, where we can go to 1800 as well as to 2600 also. These gas pressures up to 50 kPa, depending, as I told you, depending on the utility, the pressure required at the burner level, we can provide gas pressures up to 50 kPa at the utility points. These gasifiers come in different capacities, varying from 10 to 60,000 meter cube. The latest one that is coming up is an 80,000 meter cube, which I have not put in here because it's yet to be commissioned and initiated. Then we have one low pressure entrain flow gas station. This is the process flow for this. Fly ash of the primary reason for setting up this low pressure gasifier is that the fly ash or the slag that comes out from the CFBC gasifier, it's fine. It could be the raw material or the raw material for this kind of a gasifier. So this is the only reason why we would want to push this gasifier into the industry for the usage of fly ash coming out from the CFBC gasifier. Then how are we able to compliance to the environmental norms? As I told you, all our gasifiers are designed on ZLD, zero liquid discharge technology. We do not incinerate, we do not recycle. There are technologies in which the tar and the condensate water that comes out from the gas comes in a mixed state, so it's very difficult to separate the tar from the condensate waters. You have no options but to incinerate it. So, but in this, in our technology, there is nothing like that. We take condensate water at a different stage, and we extract tar at a different stage of the gasification process. So we do not incinerate at all. Dust, tars, and volatiles in final gas are kept less than 50 ppm and 30 ppm at utility stack points. We again we do not put a dent into the atmosphere as compared to the if we are using furnace oil or any other fuels. This technology would result in lesser emissions as compared to use of any other alternate fuel. Sound levels at gas stations are maintained well below 60 dB. All our blowers, all our compressor motors, all motors are on drives to make sure that the sound levels are well within limits. We are very, very concerned about wildlife, and our eardrums are very important to us. All byproducts are carefully and professionally handled and reused. Our byproducts primarily are the ash in case of fixed bed gasifier, which is sold to cement plants, which can be sold to brick making plants. For the CFBC gasifier, our fly ash is the main byproduct, which is an important can be used as a fuel for the power plants. So we care about our customers' pockets here as well. So these are the industrial applications of our gasifier. As I told you, we are primarily working on the thermal use of this gas. Our single-stage hot gas station, pyrolysis hot gas, pyrolysis coal clean gas, all these variants, we are using it for thermal applications and to various industries like steel rolling mills, DRI kilns, chemical plants, refractory making, galvanizing, ceramics, glass, rubber plants, kaolin, aluminum plants, zinc, copper plants, tile plants, insulators. So wherever gas is required for the thermal use, these gasifications come in picture. for that. And as far as for our entrain flow, we are still looking for avenues as to how to get this in line. These are a few pictures of our gasifiers. These are our single-stage hot gas stations. These are our pyrolysis clean gasifiers, both hot as well as coal gas stations. These are our CFBC gasifiers installed for different applications. Primarily, these are being set up for aluminium industry as well as for steel industry. We are moving towards an Atmanirbhar Bharat. How we are doing that? We are very pleased to inform you that all the fixed bed gasifiers, all variants are manufactured by us in India. 100% equipment is manufactured, supplied from India itself. For the fluidized bed gasifier, 80% of project supply is from India. Only critical parts and proprietary parts are being imported. So we are complying to our Honorable Prime Minister's vision of Make in India and making our India an Atmanirbhar Bharat. The future of gasification, I say it's very bright. Since we are in the middle of this conference, everybody is taking active part, so the future looks very bright. We have huge reserves of coal. As explained, India has the third largest reserves of coal in India, which needs to be gasified. 10 years to consume this huge reserve before a new energy source. We are anticipating and we are looking forward to a new energy source coming up maybe in the future. So this is the time when we should utilize and use this huge resource which we have with us that needs to be explored. Coal gasification, we feel, is the only clean and proven way to move forward in this direction. Energy demand and commodity consumptions worldwide are on the rise. Incentives being given by the Indian government, incentives such as a 20%. I was listening to technical director yesterday in his presentation. He informed us that there is a rebate of 20% revenue sharing, which will be offered for gasification process. If you're using coal for gasification, 20% of the revenue sharing will be given to the end user or to the agents who are supplying these gasifiers. So this is one very big boost for the gasification section. There's a new slide which I introduced. It's very interesting. We are talking about gasifying 100 million tons of coal in the next 10 years. I would like to share that CASE has roughly around 200 gasifiers in India, which are being used for thermal application in the industry. Now I've calculated that a normal gasifier, depending on the quality of coal, would generate something between 6,000 to 10,000 meter cube of gas per hour. So for that we would require something like 4 tons per hour. A daily consumption of coal per day would be approximately 100 tons per day. So CASE, as I told you, we have 200 gasifiers. If we are consuming 100 tons per day for 200 gasifiers in 365 days in 10 years, then we are consuming 73 million tons of coal already for the thermal application of coal gas. So I don't think so that using another 27 million tons of coal would be a great challenge for India. I think the standards should be raised. Probably we should talk about 200 or maybe 300 million tons in the next 10 years. So where gasification is going to stay? Yes, definitely gasification is going to stay. This is the future, and I feel the summit would also stay. And good luck from my side, and see you again soon. Thank you.
Thank you, Mr. George, for your presentation. We have already started getting a few questions, but we'll request the presenters to give the presentations, and then we'll take the questions. I'd request Mr. Cristian Bolda to please speak to us, to the audience, and talk to us about Leigh Creek Energy.
Thank you, Anisha, and it's good to be with you guys here, and I'm happy to see it's happening around the world. I will introduce ourselves. So we are Leigh Creek Energy. We are Australian based, and our project is in Australia. And basically, we will build a 1 million ton urea fertilizer plant where we will utilize our syngas from the underground coal gasification. So on the second page is the standard disclaimer. So let me introduce you Leigh Creek Energy. So we underground coal gasification is not a new process. This is done around the world for the last probably 100 years. Unfortunately, haven't been brought to commerciality excepting in Russia, where for the last 40 years is used for power production. We are based in South Australia, and we took over a mine, which was a surface mine, which was owned by the government and was mined for the last 70 years. And basically the mine have been closed because they reached to a point where the surface mining was not profitable anymore. Our project is about 500 kilometers north from Adelaide, and we have done to date, since we took the tenements, we have done a pilot project where basically we started the underground coal gasification. We use the process, and we operate the plant for about 6 months. And in 2019, in April, we shut it down. And on the base of the coal quality, we have upgraded our PRMS reserve with just 31% of the deep coal existing is giving us about 1153 PJs of gas on 2P reserve. In this moment of time, we are continuing monitoring the groundwater, and we are monitoring the air is part of our environmental approvals. But as you can see, and we can discuss further in more details about our pre-commercial demonstration plants. But basically, in a highly regulated environmental, highly regulated country, in a state where moving a leaf is an environmental issue, we have proven to the government, and we have proven to everybody else that we can operate continuously for 6 months plus without impacting the environment at all, and in a safe manner, which pretty much classify us as competent operator according to Australian standards. Since 2019, basically the company have progressed with the approvals, and basically, let me put on the second slide. So basically, after we have done our syngas trial, we have worked with ThyssenKrupp, and we work with other engineering companies for performing different studies and identifying possible commerciality avenues. We have proven that with the gas production, what we have done, we can produce syngas with underground coal gasification technology, and with the IP what we have under $2 per gigajoule. Our project, our trial project was performed at 500 meters. So comparing with the above ground coal gasification, basically we don't need mining. Comparing with the above ground coal gasification, we cannot gasify the coal close to surface, so have to go under 200 meters. So this is the nice part of the technology that can recover the majority of the resources which are unprofitable to do it through the traditional mining. So commerciality, as I've told you, we are not who invented this technology. We're done trials around the world. unfortunately for our predecessors, some of the successful trials have been done in countries where the gas price would not make affordable to producing gas through underground coal gasification. But as you guys in India, you are paying a high price for the gas. The same is situation in Australia, and basically is making not commercial profitable, is making more than more than expected profitable. So lately, during our approval process, we have been awarded the petroleum production license for our gas reserves, and which is pretty much the last license required before starting the commercial production. And the government, before awarding this one, is confirming the technical capabilities and the commerciality, and as well, they have to have more than 50% certainty that the project will take off in the next 24 months as commercial project. In parallel,
I think, Mr. Cristian, your slides are not changing, Mr. Cristian.
So you see now the Leigh Creek Energy. So sorry,
we are still on the first slide.
Oh, sorry. Now?
Yes, now now we can see the next slide.
Perfect. So basically, in the last year, we with our team we have worked very hard, and we got two of the environmental approvals. We got the petroleum retention license and the petroleum production license, and as well in parallel we have progressed, exactly like my predecessor have said, to investigate what are the best commerciality for the syngas. We don't want to be somebody who is just giving the feedstock. We just want to make for our company value-adding products. So on the base of the studies done, we have investigated power, we have investigated hydrogen, we have investigated to convert it in methane and put it in the domestic gas market. We have investigated the methanol and fertilizer. Fertilizer study was pretty much done by a third party, which was ThyssenKrupp, and we finalized the pre-feasibility study a couple of months ago, and our board decided to progress on building urea plants with 1 million tons per annum production. This is pretty much the first train. The initial capital cost for us will be about $2.3 billion. The commercial life of the tenement, what we have the production license, is 30 years, and the rest of the reserve, what we have, will give us another 70 years plus. So basically, on the base of how we are going with the market, how is going the fertilizer, how is going this, we will decide in the future if we build the second and the third train. On the basis of the ThyssenKrupp report, you guys, that in India, urea is bought and subsidized by the government, but on the basis of our syngas cost and the study done by ThyssenKrupp, and on the base of all the cost for the capex and opex on the high-rated country in Australia, basically we are producing the urea per ton with $109. These are Australian dollars. Hydrogen production can be done, is a potential, but unfortunately for us is not appealing, because in this moment of time doesn't exist the hydrogen market. And basically the rest of the details, the pre-tax leverage, the NPV is 3.4 billion, internal return rates, the IRR is 30%. So as you can see, is highly appealing to do value-adding products through underground coal gasification. Let me go to the next slides. So basically, this exactly what Air Products and my predecessor from Case put it in. These are all the products what you can do it from syngas. I'll not go in detail. You guys know the same like us what can be done. Next slide. How does UCG produce gas? So basically, the beauty of underground coal gasification comparing with the above ground coal gasification is you don't depend on mining. You don't disturb the surface. So we don't have to remove overburden. We don't have to dig out and have the big investment in equipment, mining equipment to increase the production to make it profitable. For us is drilling, directional drilling, meet the wells in the ground, initiate the coal, and after this just inject an oxidant. Outreach to the oxidant because again comparing with the above ground coal gasification, for us we will progress with underground coal gasification by air, which pretty much is reducing the consume of water. We don't need air separation units, and these are pretty much the big energy consumers in the facilities. So for our demonstration plants, we pretty much have done exactly like this figure. We have drilled a vertical well 500 meters in the grounds and 300 meters apart. We have done a directional drilling well, and we have gasified for 6 months the coal on the intersection. The process is simple, is easy, as much as you know what you are doing. So with the underground coal gasification, exactly like you have said, in your presentation, in Case presentation, everybody's panicking on the base of some prior incidents about the potential environmental disaster, what happened along the history. And on the basis of this one, our pilot project was highly scrutinized, and the condition for operates was humongous. So basically, for a pilot project which operated 6 months, we have drilled in deep coal 23 monitoring wells, monitoring the groundwater, monitoring any possible gas leakage, monitoring the settlement on the surface. So everything have been done to prove that the underground coal gasification is safe and we can do it. Comparing with you guys with the above ground coal gasification, I don't need to inject water because the water exists in the grounds. Even in the middle of the desert at 500 meters, the rock is saturated over million of years with water. And just by managing the pressure undergrounds and dropping your pressure under the hydrostatic, you have water available for your gasification process and improving the gas quality. But on the same time, when the syngas is coming on the outlet well, it's coming wet. We are separating on the wellhead the gas from water, and again the water will be separated and we are taking the condensate, but we are not processing the water or cleaning up the water. We are reinjecting the water and is used in the gasification process. So the process is simple, is easy. We are not impacting at all the surface. And I know that in India, the agricultural land is the value in gold. You guys, you have more. The real estate in India is more expensive than in Australia. So this is another part. Are different type of coal gasification can be done linear crib, can be done parallel crib, but this process can recover the majority of the coal which is pretty much impossible to be mined. And all the coal mine, they are mining basically the top of the iceberg. All the rest is remaining in the ground because it's too deep and cannot be mined. Where for us, as deep it is, as better it is. And I will tell you why later on. So basically you see here a sketch with the injection, oxygen or air. This one is sketch was oxygen, but pretty much you inject air or oxygen, is going in the gasification chamber, coming on the wellhead, gas cleanup, which air products as well as other are, specialists. And after this is going to power production and fertilizer production. This I forgot to mention that part of our project, we will be independent of the grid. So we will not take anything from outside. We will build our own power plants, which will be operated on our syngas, which will power up the fertilizer plants and as well the compression. So even for the compression, we will use the electrical compressors, and we don't have to waste money in the OPEX for supplying diesel. Now with the underground coal gasification versus surface coal gasification, as I've told you, we cannot compare, but are pluses and minuses. Basically for above ground, you can see on the comparison on the coal mining and transport, we don't require in UCG. For surface gasification is required the minimum quantity to maintain it. Ground disturbance, we are pretty much for drilling the wells, we need a 15 per 15 meter area for the drilling pads, for the drilling rig. And after this, basically everything is reinstated to normal. Safety, we are not putting the people in the gasifier, and basically from an engineering perspective, we have all the technology to prevent overpressurizing or any incident. So nobody is in the risk during the operation of the plants or underground coal gasification. Reaction time is pretty much for us minutes, because as soon as you stop the air injection, as soon as you stop the compressor, the coal doesn't have any oxidant, so it's turning off. Cost, we are less expensive because comparing with the surface gasification, on the faraway capex, we don't need the feedstock. We basically, our cost is drilling the holes and putting the compressors. We don't need an air separation unit because the gas is coming up, and in the cleanup process, we will remove the nitrogen cryogenically, which will be fed in the ammonia plants, and as well the CO2 will be captured and fed in the urea plant. But the beauty part of our process is that the amount of investigation and the gasification process is proving that is not leakage outside. The redundant gasifier can be used for the CO2 sequestration. So for us, comparing with other operator, we will have a compressor, put it on the venting points in the gas processing facility. We'll compress it to bring it on the leakage stage. And as you know, the CO2, 100 cubic meter of CO2 brought on leakage stage is about 2.8 cubic meters. So we will have more than enough space to put the CO2, and probably we will even discuss possibilities for others to bring the CO2. The monitoring wells, what we have for the gasification process, are already in place as the monitoring wells for the monitoring the CO2 sequestration. So basically our project will be zero CO2 emission. Syngas quality, the higher methane content do increase pressure with depths. On the surface gasifier, the same. Coal depth, we can take exactly like we are doing for our project. We can come and assess a mine which pretty much have been shut down being uneconomical, and recover all the coal what could not be extracted. Let me go on the second page. On the next page, sorry. Dust levels, we don't have dust. Particulate matter, everything is done underground. We don't have ash, all the ash is remaining in the ground. Groundwater, we don't need dewatering, like the coal seam gas. We are not depending of this one, so we don't require, and we are managing the water intake in the gasifier to maintain our syngas quality by increasing or lowering the pressure. Coal geology is best used when coal deposit has little or no structure, wherefore the mining is different. Greenhouse emission. So this is the interesting part, was the greenhouse emission, because we are not, this was a study done by Blinderman, and the gentleman from case referred Blinderman, and basically this is the CO2 emission and the NOxes and the SOx. So the SOx is pretty much non-existent. So comparing with other technologies and what have been done to date. Economic advantage is more economic than the coal mining with no capital intensive infrastructure. Commercial production is proven. Produce far more gas than any gas well in the coal seam gas industry. So basically the size of the gasifier can be up to 1.82 kilometer, depending of the rock structure above. But for our gasifier, sorry.
This is Anisha here. I'd request you to please wrap up your presentation a little quickly. We have very little time left. So, and we have another speaker after you. Could you wrap up your presentation, please?
No problem. So, economic advantage, we discussed it. Environmental, on the environmental advantage, again, we have discussed it till now. And basically, thank you. If you have questions or you want to contact us, feel free, and we would be more than happy to collaborate with yourselves.
Thank you so much, Cristian, for your presentation. We also have with us our next speaker, Mr. Damodar Mittal, the Executive Vice President of Jindal Steel and Power is with us. So I would request Mr. Mittal to please give his presentation.
Thank you, everyone. Good afternoon. I am just going to present coal gasification and the based on gasification DRI in our JSPL Angul plant. This is all about our Jindal group, where we started, and you might be knowing all the history of JSPL. We have units in Angul, Raigad, Patratu, Oman. Then we have pellet plant in Badbil, mining interest in Tensa, and we have JPL, Jindal Power, where we are having 3,400 megawatt power plant. Then now comes to gasification. Why we want to have gasification is why it is important for India, because we have huge high ash coal available, and if we compare the cost of steel through coal route and coking coal route, you can say blast furnace route, then this gasification technology is very important to produce gas through the coal. Then if we use gasifiers to generate syngas, then later on to produce DRI, this will be a good route that we have adopted in Angul plant. If we compare CO2 emission through all the routes, DRI route, BF route, you can see there is around 60% of the CO2 emission more in BF route. So in future, this DRI route through syngas will be very, very popular in coming days. And there are lot of coal-based DRI plant in India. If we compare gas-based DRI over coal-based DRI, then there are lot of good reason to change our technology to coal-based from coal-based to DRI on gas-based route. Like gas-based route, you can have less CO2, then energy consumption is very less, and DRI fine generation through the hot route is only 5%, because you are feeding all the hot DRI generated from the DRI route is to directly to arc furnace through hot link. And these are the salient feature of CGP. We have 7 number of gasifiers, and we can use 34 to 36% ash coal in these gasifiers, and these gasifiers are Lurgi design, and we need 2.4 million ton per annum if we are running this gasifier on full capacity of 225,000 cubic meter. But for this time we are using only 60% syngas. Remaining gas we have now designed to use coke oven gas from our blast furnace route. So now, to run DRI plant at 2 million ton capacity, we need only 1 lakh cubic meter of syngas, and remaining gas we are replaced from coke oven gas in existing plant. So we have surplus capacity of gasifiers, and we are thinking to go ahead either for second unit of DRI, or we may think of putting some methanol or other plants for utilizing the surplus capacity of gasifiers. These gasifiers are having basically gas cooling system, then tar separation, phenol, ammonia system, and these gasifiers, mainly the gasifiers are compact, but the byproduct area is a very big plant. I will show you the picture of gasifiers in the Angul plant. This is layout of gasifiers. You can see the one picture of gasifier, how it looks like. These are 7 numbers. You can see the coal is coming from the coal bunker, then there is coal lock valve, then gasifier. After that, this gas is being cooled in wash cooler, and then this wash cooler to primary waste heat boiler. Then it is going to rectisol unit, where we are removing the CO2 from the raw gas. Then the discharge of the ash lock, you can see the coal is, after burning, ash is coming out from the bottom. This is lump size. The coal percentage in ash is only 2 to 3%. These are the gasifier 7 numbers. You can see the pictures. And if you compare the total plant capabilities, this DRI can produce 2.2 million ton of steel through 1.8 million ton DRI, and remaining we are using hot metal from our blast furnace. This hot DRI is having 700 degree temperature, and this is going to the arc furnace. This is the DRI plant picture. You can see the vertical shaft. This is vertical shaft. Midrex. This is designed by Midrex. Gas is coming from the gasifiers. After gasifier, this pressure of the gas is 25 kg, and temperature is normal 40 degree, 50 degree centigrade. Then this gas is going to our heater, where we are heating up to 900 degree centigrade, and this 900 degree centigrade gas is going to Midrex plant. And we have one turbo expander, where we are reducing the pressure of gas from 25 to 3 kg, because our process requirement of this gas is 3 kg. So we are generating additional power from this turbo expander, because syngas is designed at 25 kg outlet pressure. This is the scheme of DRI plant. We are injecting the syngas into gas heater. Then this is going to DRI plant where we are injecting partial oxygen, because this syngas is having methane around 10 to 12%. Then this reduction furnace, hot DRI is directly going to arc furnace. If suppose there is some problem in arc furnace, we have another route where we can cool the product into the cooler, and this cold DRI is being stored in different bunkers for future use. We can reuse this DRI to the furnace. This is the flow diagram of DRI plant, where you can see the red type vertical structure, that is vertical furnace, where the syngas is going to this Midrex vertical module after heating in the gas heater up to 980 degree. Then we are injecting some oxygen to remove to convert methane. Methane is having around 12%. Then we have two routes. One is going to arc furnace. This is hot DRI. The temperature of DRI is around 7 degree. Suppose there is some problem in arc furnace, you can come down to cold DRI, where we can cool down the product up to 60 degree temperature, and we can store for further use. These are the major equipment for DRI plant: furnace, scrubbers, and process gas compressors. And this DRI plant is also having one CO2 removal system, because after this gas from the top of the DRI module, this is having CO2. We are removing the CO2 from the top gas, and this CO2, after removal of CO2, this process gas again we are using in the system. So this is having a closed cycle of the top gas, and we are injecting additional makeup gas of syngas and coke oven gas to keep continuing running this DRI plant up to 225 ton. This is the consumption of iron oxide and syngas. This syngas consumption is 660 cubic meter per ton of DRI. So we are now using 500 cubic meter of syngas, and remaining 120 or 110 equivalent syngas we have changed from by coke oven gas. The power requirement per ton of DRI is 135, and remaining items is small item. But we need to develop such kind of technology, because this is huge investment we have made in the gasification and DRI plant, and what the support we need from the government so that we can show the people this technology is cheaper, and we can promote so that people should, because it is huge investment type of plant, so people should be motivated to go for such kind of investment. So we need coal should be available from the government of India. Otherwise, because nowadays the coking coal price is only $100, and if we compare both the route, hot metal route is still cheaper than this DRI route. So if we have to go this gasifiers permanently in India, the coal should be given at certain lower price, maybe 25 paisa per GCV. Such kind of policy government should have. Otherwise, like we just started in this gasifier after long shutdown of 2 to 3 years. Why? Because of the coal was much costlier, and there was no viability of running this route. And if government is asking private sector to invest for 300 million ton of steel, then gasification is natural process where we can have our own domestic coal, own domestic iron ore, and then it will replace the need of imported coking coal. So we should have a composite Indian government policy to promote this route. Thank you very much. if any question, you can write us, and we welcome everyone to visit our gasification DRI route to inspect how it is running. Nowadays it is running very well, and we are very happy to say this month we are going to produce highest DRI through this route since inception of our plant. Thank you very much.
Thank you, Mr. Mittal, for your presentation. We have a couple of questions, so we'll take them, and I'll hand the mic to Mr. Daman Walia of Artec. Mr. Walia, can you hear us?
Yeah, yes, I can. Can you hear me?
Yes, please go ahead and ask your question.
My question is to Mr. Moniz of Air Products. There are two projects I was intrigued which you're doing in India. One is where you're an EPC contractor to produce urea from coal. And the other one which you're going to build, which will be to make methanol from coal. For both of these, my question is what do you project will be the price of the urea, and what is the price of the coal you will be getting, and same thing for methanol, and what do you project your IRR or ROI will be in India?
So Shiba, do you want to handle the more specific questions? I can then come back on a more global standpoint.
Sure, Mario. Thanks. Mr. Walia, thank you for your question. Actually, the first project which you mentioned, which is the coal to urea, there our role is as a licensor, as a technology licensor only. And there we are not doing the entire project. So you have to contact the owner, which is the Talcher Fertilizer Limited, in terms of getting the cost details. We do not have any information on that. On the second project, it is still in the bidding stage. It has not been awarded. So it is only to show that such large-scale projects are being conceived in India by Coal India and their subsidiaries. But it will become hopefully a reality in a few months from now, once the project is awarded. In terms of the cost of coal and the ROI and all that, those are typically, sensitive information, I would say, in terms of more confidential. So I would suggest you to contact us separately in terms of understanding. If you have require any understanding in terms of the economics of these kind of projects, we can help you to understand how this economics works. So it will be better to discuss separately on that. Thank you.
So as one general comment, Mr. Malia, so we're a publicly held company, right? We are on the New York Stock Exchange. And so what our CEO and our chairman says, for all this build, own, and operate model, what we strive to achieve when we invest $1 of capital is about a 10% return on that capital. So in general, obviously, it depends on country and project, but our overall goal is about a 10% return on capital. And that comes from our CEO and chairman. Price of offtake product is very dependent on region. So as Shiba said, those would be more project and specific region dependencies.
Right. Thanks, Mario, for that.
All right. We have Mr. Roshan Singh also. Roshan, go ahead, ask a question. Please unmute yourself.
Thank you. My question is to Shiba, sir. Sir, I would like to know about the market in India for SNG. From SNG produced from coal gasification, in absence of any national gas grid, and further, how do we really opt for the optimum product of coal gasification as a coal producer and not as an end user?
Is this question to Air Products? Sorry.
Yes, my question is directly to you because I feel that you would be.
Okay. Thanks for the question.
In the Indian market scenario.
So, Mr. Singh, it's an interesting question, and to simply reply to that, we have undertaken a lot of internal feasibility study to see how coal to SNG looks like, worldwide. If you see in China, for example, where the coal costs are typically lower than India, because in India the taxes and the royalties are very high on coal. So overall, the coal price, which is, at the end of the day, the delivered coal price is pretty high in India actually, compared to China. So even in China, coal to SNG has not been extremely successful. It has not been successful in the sense that the cost of SNG has not been really competitive against the natural gas prices. It used to be good, and once upon a time when natural gas prices used to be $15 and more. But in today's scenario, if you see where natural gases have crashed to $4 or $5, or maybe delivered price could be about $7. So it's very difficult to basically compare that with SNG. So we have been telling our customers, including MCL also, because MCL came up with an EOI for the coal to SNG, that SNG route in India could be a little challenging in terms of the pricing, and to compete with natural gas or RLNG, it might be a little difficult in terms of the pricing. Pricing. So we don't think that I would rather say that methanol, ammonia, urea, and some of the other basic chemicals are better in terms of value addition, in terms of getting better returns, and also in terms of the competitiveness with the global market. Whereas SNG is not really a product which might be able to fit into Indian market, because of the cost structure here. Thank you.
All right, gentlemen, thank you so much for joining us this afternoon and sparing your time and sharing with us your insights on syngas and coal gasification and the road ahead for our country, and how we can maximize the value out of coal. Yes, there are a lot of challenges, especially when it comes to alternative fuels or alternative sources of feedstock. A lot of acts will have to be done, and a strategy will have to be drawn up so that we can use abundantly available resources in a long-term sustained manner and sink in the capital cost to make it worthwhile. Thank you so much for joining us today. We're very grateful to have you with us. Thank you, Mr. Moniz, Cristian, Shibaditya, Mr. George, Mr. Mittal. Thank you so much for joining us for this session. We will conclude this session. We have a validatory session coming up after this, immediately after this, so don't go away, and do please join the validatory session. This is for everyone who is watching. Please do join the validatory session. See you then.
Thank you, Anisha.
Thank you, Anisha.
Bye-bye. Thank you.
Bye-bye.
Thank you.
Bye-bye.